Hello, and I'm at Decompute here in Singapore 2024. And with me today, I'm very pleased and very privileged to have Prakash, who is the co-founder as well as CEO of Silence Laboratories, to share some of the latest in multi-party computation highlights at this conference. So thank you so much, Jay, for your time
today. Thank you very
much
for having me.
Yes. Yeah. So Jay, I think a lot of people would ask, what are the current sort of security concerns that we have today? Some of the key concerns that makes, some of these multi-party computation security a way to address some of these concerns.
Right. So the key concern, which is also the talk of the conference and central point, is single point of failure.
Single point of
secrets.
failure.
Yeah, so secrets when in use should not be exposed at one place.
So if we take the example of, say, let's say take an example of a cryptocurrency wallet, where, I hold my own private key.
Right.
So a lot of these sort of keys get exposed.
Correct.
And that is like a single point of failure.
Correct.
Right. Okay. So can you tell us what is multi-party computation,
right,
and what are the key principles that seek to address this kind of single point of failure?
Sure. So multi-party computation is an algorithm which helps you to do computation on distributed data. This data can be secret in case of crypto. So let's imagine a contrast between two scenarios. In traditional wallets, you have private key in one place and then you sign. But you do expose private key during signature. In MPC supported wallet, your private keys are actually never ever in one place. During wallet creation process, you create key shares at different places. It can be two-party or more than two-party. Depends on the business logic. Let's imagine a two-party scenario. Your key shares will be in the cloud of the wallet provider, one key share and one on your phone. And then you can run the protocol between these two key shares and create a signature which will look like as if it's coming from one single private key. That's the core offering in this case. But there are many ways to use it. For retail wallets, you can use two key shares, or for corporate custodial solutions, you use 2 out of 3 solutions. It depends. But it's generally quite scalable.
Right. So what you're saying is that it's essentially more than just one party. That's why the name multi-party. But whether it's going to be 2 or 3,
right, correct,
it depends on implementation.
Right.
So right. So I think some audience might be a bit puzzled to understand how is that different from a multi-signature wallet.
Right. Correct. So yeah, multi-signature is a very simple concept where you actually submit 2 different signatures coming from 2 different keys directly to a smart contract or anywhere whosoever is verifying. And the code there will verify that, okay, these 2 signatures are coming or not. If they come, then yeah, you will pass it. But the problem in that is not every ecosystem supports multi-signature, number one. And number 2, in multi-signature, you expose who is the signing party, right? You get the corresponding party's ID based on the public keys. So there is a privacy concern, which is not so much important in general in practice. It depends on the use case. Plus also it's costly. Compared to the MPC, where you verify just one signature, in multi-sig you will verify 2 or more than that. So there's a cost angle, there's a scalability angle.
Okay, so what you're saying is that it's in general a lot more efficient to implement a multi-party computation than a multi-signature wallet in general.
In terms of if you want to reach the larger audience, cover all chains, and you still want to be cheaper, then yes.
I think a lot of audience will listen to this and think, okay, multi-party computation is obviously a much stronger security than the single point of failure sort of implementation of in some of these cryptocurrency wallets. But what would make it urgent for the audience to say, okay, I need the multi-party computation cryptocurrency wallets?
Right. Yeah, in terms of cryptocurrency, it's largely the fear of losing funds from a single party exposure. Attacks vector are increasing. There are complications coming up. So, but largely it won't be adopted by the user themselves. The retail company has to take a choice. So user can be informed, but yeah, they can't engineer and design a wallet, right? They have to convince their wallet provider to change. And that change is happening. People are adopting more sophisticated methods for key management policies.
So obviously this one will help the users to hedge against potential, I guess, phishing, social engineering attacks.
Yeah, potential key theft from different social engineering or actual database compromise. Yes.
Right. Okay. So I understand that multi-party computation is a concept that has been around since the 1980s, I believe. So what are the other applications outside of the cryptocurrency?
Oh, right. Okay.
Yeah.
So you can abstract it out a bit and imagine that the secret now is data. Let's say you have some data of your bank statement, right, with one bank, and you have similar data with another bank. And now these two data are secrets. And you want to compute a score basis your credit and lending history from the bank statement. One way is you will dump all data in one place. They will do the analysis. But in that practice, they learn much more information. You are trusting that party. Let's imagine a world where you can run a protocol between these two distributed data. Don't move in one place, but let them talk using multi-party computation, and you will get the output. So in case of crypto wallet, that function which is running is digital signature. In case of the example which I told, that function will be a score calculation function, which is being calculated over distributed data. So lots of privacy-preserving compute applications are coming up, either for sanction list monitoring or for collaboration between multiple companies, where they don't want to trust each other or a centralized party, or also quite heavy in ad tech, mark tech, in semiconductors, finance.
Right, okay. So obviously, more people need to understand that this is a rapidly evolving sort of
Correct. It's quite evolving. There has been a good amount of research to improve a couple of practical aspects, largely the speed. Speed improvement has been a topic of research and also engineering for a while. Now we do have implementation which are very much customized and optimized for applications which can be used.
So you talk about speed. What are the kind of complications behind the implementation that slows down the speed?
So because in general, MPC is very chatty. It's an interactive protocol. More the number of party, more the interactions will happen between them, and then that requires bandwidth, that requires communication rounds, which ultimately affects your end output time. That's one challenge. There have been works going on to pre-compute states, and then you just do one round, and then you get the output back.
So this is the second year in the row that you are running this conference.
Correct,
yes.
Yeah. Mm-hmm.
So can you just tell us, how it has evolved over the last, couple of years in terms of the conference topics and the research and development?
Yeah, the whole agenda of this conference was to fill a gap. So we felt that academic research is very much targeted toward publishing a paper in general, not always true. And then industry people are very much aloof of a couple of nuances, what is written in the paper. So these two need to meet, and we need to provide that background and platform. That was the whole idea behind the conference. Last year it was heavily focused on digital assets. This year we have tried to focus on digital assets on day one, and day two is much more about data privacy. So basically, the horizon of uses of technology like MPC or PETs is increasing, and that's what we are trying to cover. And we invite everybody through a very rigorous process, which is not based on binding to any sponsorship. It's totally based on merit of the work with the summit.
So what do you think will be the big topic for next year then?
That we have to think. The interesting thing about the space is the speed of implementing research to production is very high. Maybe AI is close to that, but in general, you get a paper published, and then you have that in production within a couple of months.
Wow.
So the field is evolving very fastly, but so far, basis our current analysis, largely it will focus more on data privacy and data collaboration privacy and creating those protocols.
Yeah, so basically more applications in the medical field, I guess. Like,
medical, finance.
Right?
Correct.
Rather than
just
focus on cryptocurrency.
Correct, yeah.
Right.
That horizon will keep on increasing largely, yes.
Right, so that will open up a lot of, I guess, services that would be available to end users if
Right.
you are able to aggregate information from different, I guess, financial service providers or medical providers
Correct, yeah,
and
yeah.
get a holistic report, right? Okay, cool. All right, okay. So Jay, thank you so much for
No,
your
thank
time
you very
today.
much for having me.
Hopefully our audience will, go away and, think about this multi-party computation.
Yeah, sure. It's a nice tool. Read about it.
Yes, yeah. So thank you so much for your time today.
Thank you.